Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem longest substring without repeating characters. Before we start, let me know if you'd like me to make more of these videos by liking and subscribing to this channel. Okay, let's begin. The problem says, given a string S, find the length of the longest substring without repeating characters. So we want to identify what kind of coding pattern we can use to solve this problem. Well, longest substring is like a subarray type of problem. And we want to look at our list here of different problems that we can solve with sliding window pattern. And we see that this is similar to a longest sequence. And so sliding window is a candidate. But let's also see how we would know that conceptually. Well, if we think about the sliding window, we want to, we're going to create a window, let's say a window of this size. And when we look inside this window here, we see that we're going to be checking for what the problem asks us for. We see there's no repeating characters inside of this window. Because there's no repeating characters inside that window, that's a candidate. There would be a length 3. And we can grow the window, and at this point we see that there is a repeating character in it. It's an A. So what do we need to do? Well, we need to shrink that window. We need to have the A at the start get removed from the window. So then we'd be left with this, and then we can go ahead and grow that window again to see if we'd find you know, a larger window size without repeating characters. So in this case, 3 ends up being the smallest window size. Okay, let's look at this one. So we start here, and that's unique. This is unique. Now we have a duplicate, so we'll shrink that window. And then we have unique, unique. So far 3 is the largest. And then we have a duplicate, and we shrink that window. Okay, so 3 ends up being the answer. Let's think about the big O for this. So the big O for this, when you're doing a sliding window problem, and you're shrinking the window, and you're sliding it, and you're growing it, we're just going over one pass of this as we either shrink the window or we grow it and we slide it. Since we're only going over one pass of this, we're going over all the n elements once, so that would be linear. Now let's go take a look at the constraints. We always want to take a consideration about the constraints, because we might have identified this as a sliding window problem, and then you'll see in other sliding window problems that they can get more involved, where you might have to do, if you are going to use the sliding window problem to solve a particular situation, you might have to do more than one pass. When you look at the constraints and you see the length of the string, that'll tip you off as to as to if it's going to be feasible, your approach or not. So linear is great with this, of course. This isn't, that's fine. And we can't get any better than linear anyway, because we have to look at all the elements at least once. We have to reveal all the elements inside the string at least once, so that we know if there is a duplicate or not. And that's obvious, right? Let me show why. So imagine we haven't revealed anything yet, then you can't really even answer the question, what's the longest substring? So if I start revealing things, I'm still not able to tell you at this point what's the longest substring. I have to reveal all the characters before I can even tell you what the longest substring would be. That would be it. Okay, great. So now what we're going to do is let's take into consideration this too. So consists of English letters, digits, symbols, and spaces. Okay, so this is going to help us to know what kind of data structure we want to use when we're keeping track of the duplicates. So since we have letters, digits, symbols, spaces, it's a pretty big character set. Why don't we go ahead and use a hash map to keep track of our characters. So what we could do is we'll keep a hash map that will keep track of our character and the location it is at, like the index. And that's going to be helpful so that when we encounter a duplicate, then we'll know where to move the start of the window. So in this case, we just hit this duplicate. We have another W here. So we want to have the first W leave the window. So this start window, we want it to move in front of that last W. And in our hash map, we'll have a marking that says W is at index 1. So go one above index 1. All right, let's take a look at this and see. So I'll set this problem up for us. So we're going to start our window at location 0 here, and we're using the hash map. So we're going to say T is at index 0. So far we have all unique letters inside of this window. So our max length right now is 1. And then now we can go ahead and grow the window. M just entered the window, so we will add M to our hash map at index 1, all unique, so the length is now 2. We grow the window, and we see M is already in the hash map. So what we're going to do at this point is we're going to see if the start of our window is before that M. And if it is, then what we need to do is move the start of our window to be 1 greater than what this M is. So we'll have the start of our window be 1 plus, and then 1 greater just be adding 1, right? So 1 plus 1, so 2. So we'll move this start of the window to 2. Okay, and then we update, and we're going to update this to 2 here. We update that to 2 because that's where the M is. So we're updating the index of where the M is, because maybe later on down the line another M comes into play and we'll have to do that same thing again. Okay, so we grow the window and we see we have a Z. So we will add this to our hash map, Z at index 3. And then we grow the window and we have a U. So U at index 4. And this is 3 window length, which is our biggest one so far. So we update our max length and we grow the window. And we see we have an X. So X at index 5, our biggest window so far. So we update it to 4 and we grow the window. Okay, we see we have a T inside of our hash map. But notice that our window start is greater than the index of that T, so we don't have to worry about it. It is outside of the window. So that's important to know. So when we write our algorithm, we'll be checking to see if it is in the hash map, then is that index smaller than our window start? And if it is, we don't have to worry about it because it's not in our window. But if it isn't, then it is in our window and we have to worry about that. And so we have to increase our window start to be one greater than that index. Okay, so 5 is our largest. Okay, so let's hop over to the code. Start writing some code for this. First we said we're going to do a hash map, so let's go ahead and write that. So we're going to use characters, and it will map to the index value, and I'll just call this M. And actually, it's better in interviews if you have a good name for these types of things. So we can call it char index map. Okay, and then next is our max length. And we'll just do integer dot, whoops, sorry. Integer dot min value to start it out. And then now what we'll do is we're going to loop over this string. So we'll have our window start be 0 and our window end be 0. And then we'll have window end less than s.length. And then window end plus plus. Okay, those are our loops. Then you want to get that character out, so you could call it like nchar. Get the char at window end. Okay, and then we said we're going to check our map to see if it's in there. Let's back up for a second here. And let's set all this out to 0. So we're currently here in our code. We just got this t out in nchar. It's now in nchar. And we want to put this inside of our map if it doesn't exist. If it does exist, we're going to do all that work. So why don't we do this? So we say if it does exist, so we have char index map dot contains key nchar. If that does exist, then what do we want to do? So what we wanted to do, let's set the scenario up. First, we got to populate some stuff here. So t equals 0, and let's go ahead and get us to a state where it did exist. So we have the m. So I'll do it iteratively here so that it will make more sense when we hit the case. So I increase it, and now look at that. The m, we checked it, and we see that it does exist. So what we want to do is we want to take this window start, and if the m is inside the window, which would mean that the window start is less than or equal to the index of the m, then we need to move the window start to be one greater than where the m's index is. Okay, so let's go ahead and get that index out then. So we're going to say char index map dot get nchar, and then we'll check to see if the windows start, and we want the windows start to be less than or equal to that index. If that would signify, I mean, we don't want it to be, but if it is, then that means it's inside the window, so we need to shrink the window. Just make a little note here that we are shrinking the window inside of this case. So if it is, then we'll say window start equals index plus 1 to get it past it. All right, let's see what happens then. So 1 passed it there like that. And then now we need to update this. And we're going to put that, so we're going to update it in the map. You know, if it is there, and if it's not there, we'll put it in there. So regardless of whether or not it was there or wasn't there, we're always going to be putting the nchar inside this map, right? So we can do that outside the if statement. and char index map.put and char window end. Okay, and then we are in our loop. We need to update our max length. Okay, and then now outside of our loop, we can return the results. So we'll say if that max length equals integer dot min value, return 0, otherwise return max length. And this all looks good. Let's run this. All right, then we'll submit it. Great. And then let's take a look at the Python code. All right, so for the Python people out there, same thing written in the Python syntax and style. The only difference is I'm just going to start that max length out at -1, so I don't have to import the SYS min. And your max length is, you're never going to have a negative length anyway, so this is a good one to start it out at. -1 length, I mean. There's our map, and so we're doing the same process here, and then we return that 0 if we didn't find anything, otherwise the max length. So we'll run that, and then we'll submit that. Great. All right, well, thank you for watching the video. If you want me to make more of these videos, then please like and subscribe to let me know that. All right, well, have a good rest of your day, and I'll talk to you later.